Excellent. Thank you. Thanks very much for the introduction, and really excited to be here today. So I'm gonna kick us off. I don't see the slides. Oh, there we go. Okay, great. So look, thank you for the opportunity to speak on this topic. I think really enjoyed the panel. I think you got a great perspective from different industries, different players, different technology spaces. What I want to try to do today is give you a perspective on what the circular economy ambition means for the chemical industry and how we're approaching it. So I'm going to advance us to the first, maybe kind of ground everybody on the petrochemical industry. And probably for most people in the audience, you understand this footprint. But let me just give you just a quick description, right? We take the traditional feedstocks from the energy sector, crude oil, gas, coal. We transform these through a few unit operations, right? Reformers and steam crackers primarily. You heard me mention that before, to produce the building blocks that we use. And then some of those are further transformed in other processes like methanol to olefins and others. But in general, we take these feedstocks, we transform them through a select few number of chemical transformations to make the building blocks of olefins, of alcohols, of ammonia, etc., and then use those to build all the products that you're used to seeing every day, all the key products in the consumer side that you're used to. Trying to get it to advance. So when we think about sustainability for the chemical industry, what do we mean? Right? We look at safer chemistry, right? How do we make the products that we make safer with less environmental impact? We focus on sustainable products, right? How do we make products that are enabling for sustainable industries, like materials for solar and wind, et cetera? But I think more and more, and I think why we're having this discussion in this session today, more and more we're focused on the latter two, right? How do we develop circular chemistries that could be enabling for delivering a circular, recycled set of products? And how do we drive carbon efficiency and circular carbon? The reality is, though, the chemical industry is one of the most difficult to abate sectors. And that has a lot to do with the capital infrastructure, and even competition and loss of profitability are some of the concerns, right, for driving these sustainable transitions. And that's a lot of what we just talked about in the previous sector because of the complexity of the capital infrastructure and costs associated with making that transition happen. But the reality is, and again, we touched on this in the panel, this is not a dynamic that's going away. The reality is that we today are facing consumer and NGO pressure. That's translating into pressure at the brand owner level, right? Brand owners are making commitments on the reduction of the increased use of recycled plastic, the reduction in carbon emissions, the reduction of their carbon footprints. And as we've been discussing as well, the regulatory environment is clearly changing, whether it's the EU Green Deal, the energy efficiency and circular carbon economy targets within KSA, whether it's China's ban on plastic waste, their commitment to go carbon neutral by 2060, and many, many other examples. This is a reality of the world that we live in today. The world is changing, and the industry has to adapt to this changing world. And I guess the last point I would touch on is that it's also touching the financial markets. And you clearly see this example from BlackRock, but you see this in many other financial institutions, more focus on broader ESG goals of companies and more focus around capital allocation associated with circular economies. So let's talk about circular carbon economy, right? And I think, back to the discussion that we were having in the panel, when you look at CO2 emissions for the chemical industry, a couple of things to note, right? And this is why it's important to think about what changes you try to drive. The majority of the emissions come from the production of olefins, methanol, and ammonia. So there's no question over that. That takes you back to crackers. It takes you to reformers. And the production of ammonia. So clear process technologies. Hydrogen is clearly a player in those technologies and can be, but also these are highly energy intensive processes. And actually, I think what's most important, I think missed a lot of times by people that study our industry, is that the carbon emissions are predominantly a result of the energy used. 85% of the carbon is a result of the energy used to drive the processes. Only 15% of the carbon is a result of the chemistry itself, through byproducts or losses or inefficiencies. So if you're going to address carbon neutrality, if you're going to move towards a circular carbon economy and to address low carbon emissions, you have to address the energy problem. And if you don't address, essentially, what do I mean by the energy problem? How do you deliver heat? Because that's really what drives these processes. I apologize, there's just a bit of a delay on the clicker. So the World Economic Forum, is very engaged with across the industry, and I just show one platform that we're engaged in. Many players here working on the low carbon emitting technologies platform. So you see the industry is engaged here. We are collaborating together to drive this change. You see, I think, collaboration at an unheard of level for the players in the industry, many of whom have competitive portfolios, and that group has sponsored the technology leaders from many of the leading companies in the industry and those that support the industry to drive investment around the change. And what you see here is, as part of that platform, there really are 5 clusters that have really been put together. And I think very aligned to the discussion that we had earlier. Carbon capture and utilization is a clear piece of the equation there, and storage, obviously. Biomass is a way to bring carbon emissions down, is a clear stream. Electrification, that you heard me mention as well. Clearly hydrogen and moving towards green hydrogen or alternative hydrogen production. And then waste processing and the plastic equation, because the reality is a lot of the carbon emissions as a waste today come from the incineration of plastic. And if we can't address a circular vision for plastics, you're not going to be able to really address a circular carbon economy as well. So this is a very active area of engagement. This platform is now almost through its second year, and we're now moving into the phase of really defining key investment projects at the pilot stage to help drive this transition forward, but also engaging with policy and financing work streams to help work and collaborate at a global level around the needed regulatory support and finance support to make these happen. So very proud of our engagement here and also leading one of the streams, but also very proud to be a part of this broader collaboration, because collaboration at the industry level is going to be essential for success. But what I want to transition to is, going back to the discussion that we had on hydrogen, it's very important that we understand how to address it in the most efficient way. How do we address CO2 in the most efficient way? And I'll just take us all back to a little bit of, our college thermodynamics class, but the challenge for CO2 utilization, right? And the challenge you'll hear many mention carbon capture and utilization. You'll hear the use of hydrogen as a way to drive CO2 and usage. And there will be cases where that clearly makes sense. But having said that, thermodynamics tell us that it's very challenging to convert CO2, and it's not something that we can change because we have a better catalyst or a better process. That by reacting CO2 as a feedstock, you actually have to put enough energy in to drive that equation to happen, that reaction to happen, and that typically then results in more CO2 production or greater use of energy to make that process happen if it's renewable energy. So the reality is we need to make sure that we're focused on renewable energy for sure, because if we're going to drive these reactions, we need to have a low carbon footprint, but also the demands, and I think highlighted actually at the beginning by the scale with which a reformer and actually a cracker, which is worse, need that energy. It's very critical that we use that renewable energy the most effective way possible. And I think that's really where the focus at SABIC is how do we do that in a way that's most effective for the industry? And so I'll just take this example of methanol. You take the example of methanol and say, okay, I traditionally make methanol via reformer and production of syngas and conversion of that syngas to methanol. I can really approach a low carbon methanol 2 ways. I can electrify using renewable electricity, generate the hydrogen from water splitting, react that hydrogen with CO2 and produce methanol. That's one path. The other would be to electrify the reformer and produce that methanol directly. And what you see is that both can give you a low carbon footprint, but the reality is there's a significant reduction of the energy required to produce that methanol, and that via electrification of the reformer. And again, these are the kind of calculations that are very important to understand, is that if you're going to be constrained over the cost of renewable electricity, and you're going to be constrained over the availability of that electricity for the chemical industry, you need to use it the most effective way possible. And that's why we're very focused on electrification as a platform for ourselves. because again, the effectiveness of the use of that renewable energy is going to be what's key. This just gives you kind of a breakdown of all the different kind of example processes that leverage that impact CO2 emissions, taking everything from the energy side to transportation to chemicals. And again, what you see is if you just sort of compare a coal-based process for methanol, electrification of the reformer, and electrolysis to produce hydrogen and reactive with CO2. Obviously, replacing coal as a path is by far the biggest impact for reducing CO2 emissions. But clearly, the role of electrifying the reformer is significantly better as you go further from coal to the other feedstocks. Is certainly better than electrolysis to produce hydrogen. What you also see, though, is the critical role that the transportation sectors and the power sectors play in overall carbon efficiency. And so, again, the petrochemical industry plays a part, but you see the considerable role that these other industries also play in driving low emissions. So when it comes to electrification, how can electrification play a role? Clearly, you can use electricity to drive, mechanical equipment. You can use it for e-heaters, e-vaporizers, or coolers, and you can use it in furnaces. And I use the example of steam methane reforming or steam cracking, as we highlighted. In most of these cases, it's more energy efficient to electrify these processes. So not only will it help drive low carbon emissions if we're using renewable electricity, but it also provides you a more efficient solution than we're currently using today. So that's why there is an opportunity here. We obviously have a significant transition as an industry to prepare for the renewable energy needs. But in terms of driving our operations, we can actually be more efficient and drive low carbon at the same time. However, I want to sort of pivot and say we also have to address the plastics challenges for the economy, for the industry as well. And I just will highlight this study, which basically just gives you a perspective on what do we mean around the plastics end of life and the plastic end of use challenge. And this dynamic, which is one probably many of you have seen, just gives you a perspective on what happens today. And the result is very little of the plastic that we use gets recycled back and used. Right? In fact, the bulk of it goes into landfill or is lost to the environment, and that's really what's driving this focus on plastic waste, which is also a critical issue for the industry and connected to a circular carbon economy as well. Much like in the energy space and the low carbon space, enabling infrastructure and standards are necessary. The trade-off between the different processing solutions to solve the problem are critical, whether it's capital, conversion, yield, conversion, energy, and emissions, which is why, again, it plays into this carbon economy discussion, waste composition tolerance, and distributed versus large-scale infrastructure investments. The concept is to move forward from a linear to a circular economy, right? As opposed to the current linear path we take today, where the cracker produces the products, they're then taken and converted by a converter into a product, to a form that's used for a package. The consumer purchases it, they put it in the waste, and then that either goes to energy recovery or the landfill. We have to have a transformation of the industry on this as well. And the first step is obviously mechanical recycling. Mechanical recycling can play a critical role in bringing that material back, bringing it back to a converter who can reuse that material to produce new products. So that's an efficient way to also keep the carbon in the system as opposed to letting the carbon leak out to the environment. But mechanical recycling has its limits because many products can't be recycled back and be used for the same application. So taking medical waste and recycling that back into food packaging, for example, and many other examples such as this. So there needs to be other solutions, and we're a big proponent of chemical recycling, or many will call advanced recycling, where you can take that plastic waste back to feedstock, back to a steam cracker, and make the whole process circular as well. It's a big area of focus for SABIC and many in the industry as well. And of course, as we do this, bringing in the use of renewables into the equation, whether it be renewable energy or renewable feedstocks, to help drive the efficiency and the carbon footprint of these operations downward. Collaboration models, you saw the example of the World Economic Forum LCET initiative, but I would just highlight the Alliance to End Plastic Waste, the World Plastic Council, and many others are examples of how the industry is working together to address these challenges as well. Very proud of our engagement in both of these. But these are exciting because they're taking real action, real dollars, real investment, real projects to drive solutions in what is a very challenging space. So when I kind of pivot here at the end to just to SABIC, right? And you look at our focus, right? Our sustainability priorities are built, of course, on a foundation of environmental health and safety and governance and integrity. But really, there are four key pillars, right? It's innovation and sustainable solutions. Right? We view that technology is critical to enabling our sustainability priorities on the circular carbon and circular plastic solutions needed for the industry. The circular economy is a critical priority for us in helping to enable that circular economy with real pilot solutions that can be scaled. Climate and energy, and resource efficiency, right? So clearly, these are our four priorities. And if you look at our investments in this space, excuse me, we're very proud of our True Circle platform because we've brought this now into the market. Now it's been over a year where we really, I think, brought a healthy portfolio of products and services to the industry. So into the consumer and the value chain. So the portfolio for True Circle involves mechanically recycled products, our certified circular products, which are based on advanced recycling, certified renewable products, as well as services designed for recyclability so that we can work with the value chain to design products and solutions that enable higher circularity in the product itself, and closed loop initiatives where we work with retailers and converters and brand owners in the value chain to keep the products within that chain and make a more effective circular solution. So we're very engaged in trying to work across the industry, but also with the value chain to find solutions that can enable not only new products and new effective solutions, but services and ways to work across the industry in different ways to deliver these solutions. When you look at our commitment to the circular economy ambition, what I would highlight is really if you've seen the 4 R's from the G20, the reduce, recycle, reuse, and remove nomenclature, right? When it comes to carbon and to plastic, on the remove side, clearly, which ties to CCS, right? We're clearly engaged in CCS and CCU, and the example I give is, we have one of the world's largest CO2 purification and reuse investments in our United facility in KSA, where we're taking that CO2 and using it to produce methanol. In that facility, that works, and it's an effective solution at that site. But again, as I highlighted earlier, as we go forward, renewable energy and electrification of assets likely will be a better solution in many locations for producing methanol, but we're very engaged in applying those kind of solutions where feasible. On the reuse side, we're clearly engaged with True Circle around our closed loop initiatives and design for recyclability. As I highlighted on the recycle category, we're very involved in mechanical and chemical recycling through those two pillars. Again, our connections to the World Economic Forum, the World Plastic Council, and the Alliance to End Plastic Waste. And on the reduce side, how do we reduce the production, which I think is the most critical thing for the industry? Advancing circular renewable polymers, advancing the use of renewable electricity. You see big announcements in the kingdom around the use of renewable energy. You see the announcements with our partnership with NEOM, but also you may have seen the announcement where we've converted our Cartagena facility will be converted completely over to renewable energy to support its production of plastics. And also our investments in technology, electrified furnaces, and as well as startup investments that we have in companies like QPinch and MTEX that are driving more efficient separation or energy recovery processes. So look, I think it takes a portfolio of solutions. This isn't going to be something that's incrementally solved by one or two little small steps. It takes some big changes, but it takes a portfolio of approaches to address the whole footprint of the petrochemical industry. I'm really proud of our focus here. I would just pivot us, just for the sake of time, to the end. Really say what's really needed, right? What are the needs to enable a circular economy? We need to continue to invest in the technical talent in our systems. We need the best technology, whether it be material science, engineering, modeling, digitalization. We need to increase the talent pool for our industry. We need to drive science-based prioritization. We need to make sure that as we're making choices on the solutions, whether it be hydrogen or renewable energy for electrification or other solutions like CCU and CCS, that we base it on prioritization of the resources and that it's based on the right science-based solutions, and that we invest in breakthrough R&D and technology demonstration, and that we're supported by governments and by our companies to drive these sorts of investments to demonstrate and de-risk these technologies, whether it be energy storage, recycling, electrification, bio-based feedstocks, examples we covered, hydrogen, CCU, CCS, and many others. We need policy, finance, and infrastructure support, availability of financial capital, sound policy and regulatory frameworks, enabling infrastructure and standards to drive this, and to drive it so that we can invest for the long term to make sure that we're making the right capital decisions. And recognition for the Scope 2 and Scope 3 greenhouse gas emissions as well, which are a big deal for the downstream industry. And lastly, collaboration. Right, we're going to have to collaborate at the industry level, cross-sector, public-private, addressing the regulatory, finance, technology, and market hurdles, right, which are significant. And so some of the traditional ways with which we have collaborated and the risks around intellectual property and sharing and the investment risk and sharing and the value at the end, these models have to change, because for us to tackle this as an industry, it's going to require that level of collaboration. And with that, I will conclude and really just thank the organizers for the opportunity to speak, and look forward to taking a few questions at this time.
Thank you very much, Bob. I feel awful because I know you've been live for so long now. You have an extreme energy level, which I'm very jealous of. I think you were fantastic on the panel. And no, because I know you're coming in from Houston as well, so it's quite early and still early in the morning. So I do appreciate it. We all appreciate it as well. So I think the panel was brilliant that you were on. I think that really opened up some interesting points about decarbonisation. I think first point is fantastic what SABIC is doing on the sustainability front. I think the NEON project, the initiative with hydrogen is a fantastic thing to hear, and I think that's very inspiring. And it should be for a lot of refineries and manufacturers who attend this show. So really, really well done for that. I'd like to sort of ask you maybe 2 or 3 questions, because, I found the presentation interesting and very, very insightful as well. What do you see as critical to enabling a low or net zero footprint for the chemical industry?
Yeah, as I tried to highlight in the talk, I think, for the petrochemical industry, it is, although it seems very complex, the reality is the bulk of our products are very few. The majority of the products come down to products made from olefins, products made from reformers like methanol and hydrogen, and therefore ammonia, which is also converted. So when you think about those products, it's essential that you come up with solutions that can decarbonize those streams, because if you don't decarbonize those, you really don't change the footprint of the industry. Although CCS can play a role in areas like reformers and production of methanol and others because of the concentration of CO2 that you can separate, the cracker is a much more challenging target for those, right? The reality is the CO2 that's produced is much more dilute, much harder to manage. That's why if you're going to have an impact on the industry and do it in a way that can foreseeably provide a footprint for the future, renewable energy usage within those assets is essential. And again, it's converting heat from fossil fuels to electricity, right? So making that transition of driving heat generation through new sources is going to be the most critical piece of that equation. Certainly green hydrogen plays a role, and I think when you look at ammonia and urea production, that's going to be a central player in the future, maybe blue today and green in the future. But the reality is, for addressing methanol, for addressing the olefins and many of our products downstream that come from those, it's critical that we have a path towards generating effective processes that use heat from electricity, which is very doable technically, but it's a significant change for the footprint of these processes. It's going to require collaboration, not just on the materials of construction and the approaches to generate the heat, but on the full integration of those processes, right? Because just like in the refining sector, the petrochemical sector is very effective at using all of the heat and process integration to deliver the lowest cost, right? But once you change one of those inputs and you take and convert that heat to electricity, you've taken an input out of that integration. And so you've got to make sure that you can run all the other downstream equipment in the most effective way possible. So there's a lot of work on process and heat integration, on obviously the furnace itself and how to design those and how to operate these processes in the most efficient way, which will require significant investment in piloting, significant industry collaborations, both at the peer group level, but also with other players. And lastly, to make this fully happen, it requires a collaboration across value chains and industries, right? Across sectors between the petrochemical industry and the energy side of the equation, like electricity producer side of the equation, and at the government level to drive the right incentives for the investment and in this transition to happen. So look, this is a journey, but a very achievable one. But it's going to take significant investment and some risk tolerance in these initial stages to make these transitions happen.
Interesting you say about the investment and risks. What other roadblocks do you see preventing this? Because obviously it's a big journey and it's going to be, I assume, a very long journey. What can sort of hinder this?
Yeah, I think there are a lot of risks, obviously, in any significant transition. But I mean, I would just throw a few things out, right? I mean, I think uncertainty over renewable energy availability and price, right? I think that long term we can probably have a good view of what that looks like, but over the next 10 years, I think we probably expect to see a lot of volatility in that. I think energy storage is a question, right? How you effectively can supply renewable energy to these facilities in a way that you can continue operations and effectively produce reliably the products without disruption. Do you have to balance that with petrochemical supply? Do you have to run hybrid facilities? Do you need to have energy storage as a key part of that equation? I think these are the kind of questions on how you're going to make that transition happen. And I think overall the risk piece that I would also highlight is just recognize that in a petrochemical complex, the cracker is the beginning of that petrochemical complex, and so it's the one area where you're unwilling to take significant risk because every other downstream process requires that cracker to run effectively.
Yeah, exactly.
So it's essential that you have solutions that can be tested, validated, and can work, and that there's a way to probably transition over time the furnaces in the cracker from petrochemical feedstock to electricity. So thinking about how you effectively do that transition away to moderate that risk is going to be essential.
Yeah, it's interesting that what you said about that as well. What about collaboration? Because obviously we heard it on your panel. We've heard it throughout the day. Actually, we heard it from the start with Carlos's keynote. How significant is collaboration going to be in your sector, especially achieving this goal of sort of going net zero? Because I assume it's going to have its own challenges. But what's your sort of interpretation of that?
Yeah, look, I think we see it as essential. I think that, especially in this next decade where a number of these risks, whether it be the risk of renewable energy, whether it be the access to financial capital, whether it be the technology risks that have to be taken, partnership is a way to mitigate that risk. I think, selected partnerships with players that bring technology, business and regulatory expertise that can work together to drive this, I think make a lot of sense. I think you have to do that at the right level of collaboration. I mean, I think, bringing 10 parties together to do a pilot project is tough. But bringing a few players that can mitigate that risk, how the industry is going to make that technology available to others in the market, I think is a critical piece of that too. I think that we have to be comfortable collaborating in a different way, that we're going to obviously develop solutions and processes, but that we're going to have to find models for bringing that technology through licensing or other approaches to others in the market. So I think that's a significant change of making that open and more available. And I think cross-sector collaboration is, I think unique. Whether it's the plastic issue or the carbon issue, you have new value chain entrants. You have the waste collectors on the plastic side that are now a part of your value chain now, the waste converters. And in this area of decarbonization, you have the renewable energy side of the equation, or the electricity producers, the grid operators. You have different value chain players that you maybe didn't think of, even though they might have been there. You didn't think of them in the same way. They're much more critical parts of your value chain. And I think that's a big change, because we have to be comfortable collaborating with industries that don't speak the same language. And we've certainly seen this in the World Economic Forum, that we have different drivers. We don't necessarily speak in the same way and create value in the same way, but we're going to have to find ways to collaborate as we take on that risk together.
That's a fantastic way to conclude. I would ask a couple more, but I've run out of time. I'm actually a little bit over, but it's been a brilliantly crafted presentation. Thank you so much, Bob. I'm very honored. We're very honored to have you. Actually, as one of our key
honors all mine. So thank you very much.
It's been really fantastic. So thank you very much for this, and hopefully we'll speak again soon on this matter.
Excellent. Thank you, Adam. Thank you, everyone.
Thanks, Bob.